This video aims to explain the theory of the dot product rule, drawing on important rules that need to be followed whilst using the dot product in engineering mechanics. The dot product is defined by the rule vector A dotted with vector B equals scalar A multiplied by scalar B multiplied by the cosine of the angle between the two vectors. The dot product follows three laws, and the first law is the commutative law, and this states vector A dotted with vector B equals vector B dotted with vector A. The second law is the scaling law, which states vector A dotted with vector B multiplied by a scaling factor is the same as that scaling factor multiplied by vector A dotted with vector B. The distributive law is the third law, and this states that vector A dotted with vector B plus vector D is equal to vector A dotted with vector B plus vector A dotted with vector D. Other important properties to remember about the dot product rule is a unit vector dotted with itself equals 1. Now this can be found from the basic rule of A vector dotted with B vector equals AB cos theta. Now taking the magnitude of the unit vector equaling 1, we can sub the unit vector back in, substitute the magnitudes into the equation, take the cosine of the angle between the two vectors, which is 0 degrees due to them pointing in the same direction, calculate this, and it equals 1. From this property we can derive that any two unit vector letters that are the same and are dotted together equals 1, and this can be found also from taking the magnitude of this unit vector, subbing it into the equation, knowing that the directions are the same, therefore there's no angle between them, calculating this and knowing it's equal 1. Another important property to remember is if two different letters are dotted with each other, this equals 0. And this is because, again, you sub in the magnitudes in the equation and then take the angle between the two vectors, which are 90 degrees, calculate this, and it equals 0. Another important property of the dot product is the rule which allows us to calculate the dot product of two vectors expressed in Cartesian vector form. The rule is vector A dotted with vector B is equal to the x component of A multiplied the x component of B plus the y component of A multiplied by the y component of B plus the z component of A multiplied by the z component of B. This property can be proven by the distributive law, and to do this you multiply out each factor with inside the brackets. So the first thing you would do is take the AX value and multiply it by the BX, AX multiplied by the BY, and the AX multiplied by the BZ. The next you would take the AYs and multiply by the BX, AY multiplied by the BY, AY multiplied by the BZ, and the AZ multiplied by BX, AZ multiplied by BY, and AZ multiplied by BZ. If this multiplication process is done correctly, you should end up with an equation which looks like what is on the screen below. To simplify this equation, we need to note that a letter dotted with itself is equal to 1, and different letters dotted with each other are equal to 0. From this, we can simplify each letter that is the same is equaling to 1, and the rest of them equaling 0. If this equation is rewritten, we'll end up with the same equation that we have above.